Now let's look at the later part of this evolution, from the flowering of science towards what we might recognize as a modern form of science, and some of the major figures in this progression. The flow of information increased dramatically around the time of the Royal Society, and it was in the form of science clubs, societies, mostly men of course at this time, informal. Often they were wealthy, again, or well-educated. We can see that the Royal Society was essentially the first, but within a decade or two, similar societies or clubs were founded around Europe, and the number of these started to take off in the 18th century until there were hundreds and then thousands. People were traveling around Europe, and this led to the flow of scientific information and ideas. We can also see the influence of the Industrial Revolution and the interrelation between science knowledge and mathematics and enterprise, economics, and the growing industrial might of the United Kingdom and then the United States. Here are some of the major inventions of the early Industrial Revolution: the blast furnace, the spinning jenny, the steam engine, and the trains that were developed in the very early 19th century. Also the paving of the roads that followed soon after. We can see from these curves of relative per capita industrialization how England, of course, the UK, led the way, but then other countries soon followed, and the United States embarked on a meteoric rise of an industrial revolution through the latter part of the 19th century. Other major figures through this progression were Robert Boyle, who wrote an influential book called The Skeptical Chemist and laid down the foundations of modern chemistry. Understanding chemistry, of course, is at the heart of modern manufacturing and industrial processes, so it fuels the Industrial Revolution in the late 17th century. We have Robert Hooke, who is known, of course, for working with Newton and then being against Newton and getting to war with Newton in his physics. But Robert Hooke also used the microscope in innovative ways and laid down the foundations for understanding the basis of biological living organisms and cells. Newton, of course, we know is justly famous for his work on mathematics and physics. But then in the world of geology, in a similar time frame, we have James Hutton and the idea of the endless earth, the idea that the earth was not formed recently, as in biblical accounts 6,000 years ago, but had a long and slow history of changes and evolution over spans of time that must have been tens or hundreds of millions of years. This is the birth of modern geology. Not just the Royal Society, but the Royal Institution and other major institutions were founded to gather researchers, to give public lectures, and to spread the word of these new inventions and discoveries. It moved eventually into other areas. We have Charles Babbage doing his work in the early part of the 19th century, who developed the programmable computer. We have Darwin in the middle part of the 19th century, laying down the foundation work for natural selection and evolution. And a little closer to the end of the century, the magnificent work of James Clerk Maxwell, fellow Scotsman, Electricity and Magnetism, the basic mathematical and physical understanding of light. And Kelvin, who did analogous work on energy and thermodynamics, laying down laws of physics that are still with us today. And that's the end of this module.